Hi, Kingston. How are you?
I'm good.
Okay.
Uh,
You are on that 2015 speeding, right?
yeah. No, the contaminated milk.
Hmm?
I finished speeding and painting the fences, but I'm stuck on contaminated milk.
Can you give me the problem year number?
2015, problem 3, bronze.
Problem 3, 2015 bronze. So the speeding you already finished.
Yeah,
2015 December, right?
uh-huh.
Problem 3 is this one called cow jack.
No,
Oh, this is 2014. I'm sorry. I get the wrong one. It's 1 year before. It's 14, 15, so it should be 15, 16. I'm sorry. What's the name of the program again?
contaminated milk.
Contaminated milk. Bad milk. Okay, this one is called bad milk. Let me see. This one is 2015 bronze problem 3, bad milk. Okay.
Mm.
Let me see. This one a little bit complicated. Hmm. Okay, let's see. So farmer jam known for widely quality of the milk. So it actually, this one need to do backtracking as far as I remember. Need to do backtracking because you need to base on the symptom to backtrack which one caused the problem. Okay,
Yeah.
so the quality of milk produced at the phone hosting milk testing party N of the best friends. Unfortunately, there are M type of the milk at the party. So this one I remember need to use map. So basically, exactly one of them gone bad, but farmers do not know which one go bad. So you can only use the friend's symptom to look at it. Okay, so anyone who drink the bad milk later becomes sick. If you so there are M type of the milk for the party, and this M type of milk being fed to the N party of the people. Whoever has the problem then means some type of the milk is wrong. Okay, anyway, that's that. You're given a transcript of the bad milk or whatever. Okay, keep going. And then input. Input, you have the number of the N number of the people and number of the milk, and then D and S. D is the number of the lines. So it's an integer that actually indicate that the person P drink milk M at the time T. So they are D line. So this D line is a D line, each line talking about who drink what at what time. Okay. And then S line is to put into two integers, indicate a person gets sick at certain time. So this is the sick time. S is the sick time. D is the drinking time. Okay, so basically your drinking time need to be before your sick time. So your sick time, if you have a certain sick time, anything that he shrink before it is specific will be in problem. So let's look at this one. You have three people, four type of milk, and then seven drinking record. Two sick time is 1 3 and 2 8. Okay, so type 1. Sorry, this is type 1. The two number are person and time. Okay, so there are three people. So 1, 2, 3, three people. Number 1 sick at the time 3. Number 2 sick at the 8. So based on this three number ones, number 1. So these are 7 drinking records. 7 drinking records. Let's look at 7 drinking records. 7 drinking records are N, M, and T. Okay, so it's actually person, milk type. So person 1 drinking time, this is 3, so it's a 1, 2 leads. So these are actually possibly causing the problems. This time 4 will not cause these problems, right? It will not. And then number 2 person's problem is actually coming from number 2 is 8. So both these and these will cause the problem. Okay, so these are whatever we have so far. So here, what they want to have the output. Output is a single integer speech by the minimum number of the dose of the medicine need to obtain. He guaranteed that he was sufficiently many doses that people become sick both during and after the party. So how many people got dosed would be enough. So let's see. Okay, so this need to write the right data structure. So a milk is a supposition. So these are rules that we summarized. A milk is a supposititious is bad if a person took it before become sick. So based on this rule, you will actually suspect which milk may be wrong. So so that's a rule. You actually this one 3. You will actually based on the time 1 these based on these numbers. To determine this different milk may be wrong. So 1, 4, 2, 1, 4, 2 may be wrong because of the person number 1. This 8 is actually you have 5, 7. So you 1, 2 may be wrong. But there are only possibly 2 wrong things since 2 people get sick. Okay, whatever. So a milk is good if a sick person took it. If a sick person took it after it becomes sick. Okay, a milk is good if a sick person took it. So a person sick at certain time, but if he took a milk after the milk, that we can prove that the milk is okay. Okay, this rule is okay.
Wait, but what if he takes the milk and then just gets sick, but then takes it again after? Because he can take milk.
Then you cannot prove it. You cannot. This actually is that this milk is good if it only taken after the milk, after the sick.
Oh.
So a milk is good if a sick person never take that one. Okay, so these are the 3 rules. You use these 3 rules to rule out the possibility. So right here, you can have a data structure of P, M, T, T, T. Okay, so these are P's are the people, I think. Okay. M is the milk type, okay? The different drinking times, these are the different drinking times, okay? And then you have a sig array. Sig array are if the person is sick, so you actually create a sig array. A bed array is recording a certain milk is bed, okay? So then there is a took matrix. Who took milk? So you have person person versus milk type to recording who took which type. Okay, there's a matrix of that. Okay, based on that, you try to rule out. You have to actually figure out which are really the bad milks. So based on this data you read in, you actually figure out what are the bad milks. Okay, I think this one is only like that. Okay, this problem is only like that. So let's see. So it's an implementation of those rules. Okay, so you basically preparing the NDS, this different number is no problem, right? This
Yeah.
PTT is no problem. This took array no problem. Okay, now you read in your this one we drop by one because it's 1 to n, but we change it to 0 to n minus 1. Is that okay?
Yeah.
No problem. And the keep the timestamp, so time we don't want to adjust. So you actually have the PI and the MI. These are the who took what milk. Is that okay?
Yeah.
Okay. So these are the drinking times. Drinking time you put into these. And then your sick time you actually mark which person is sick at what time. Okay.
Mm.
So this information we got that this I think this just reading the information so far. Now a person is sick before taking the milk, then the milk is a sick person. A person is sick before taking the milk, then actually the milk is okay. So basically, bad. Okay, this one is multiplied. This is rule number one. Not rule number two. You want to change the bed array. Okay. So far bed we have the drinking time and sick time. We do not have the bed. Bed and the sick are empty right now. Okay. Now we actually would mark which one is okay. Which one is okay if a person you are sick and your drinking time is bigger than the sick time. Your drinking time is bigger than sick time, then your bed of that person of that milk should be forced, right? This is dual
Yeah.
number two. So this one is dual number two. And then you prepare another one. This one is a sick person. A person is sick and never took the milk. Okay, so you actually is sick, and based on the taking table, we have a taking table. We actually do set up right here. So if he never take the milk, a person is sick and never take, then those milk are okay. Okay, so this part is also okay. Now next one is like you would like to find the maximum number. Maximum number of what? You would like to count the number of the person who actually have the maximum number of the bad milk that they
Mm.
they drink bad milk. So you go to every type of a milk. If the milk is okay, then you don't need to check it. If the
Mm.
milk is not okay, you will check. Check what? Whoever take the milk, that guy need to be treated. So the counter will increase.
Mm.
So then you actually, so basically you go to check, you have any type of the milk. So each one of the milk, if it is actually bad, then you go to check who drink it. And then there will be how many number of people have drink that type of the milk. Then they may need to be treated. And then based on the different type of milk, you figure out which one need to have maximum number of the doses.
Uh,
That's it. It's probably only like that.
okay.
Is that okay?
Yeah.
Yeah,
Uh, Wait, can I show you my code? Because
yeah.
I did it a little bit differently.
Key point, okay, before you turn to you, I think key point is the summary of these three rules.
Mm.
You need to figure out these three rules. It is kind of like a filter problem. You use
Mm.
the filter to filter out the good milk and bad milk.
Yeah.
Okay. So if you cannot find out these three rules, then this problem you cannot solve it.
Mm.
Okay, your turn. You show me.
Um, so basically I had the person, milk, and time, so the timestamps.
Yeah, that part the same. Okay.
And then over here it's like if they took it before, then it's possible that the milk is bad. So I just add it and then I count how many people took the milk before they got sick. And over here, if the number of people that took it and got sick is equal to S, so everyone that got sick also took the milk, then it's possible that the milk is bad. So then I count how many people took it and I find the maximum with the answer. And
Yeah,
then,
so your problem right now actually let me shortly I think you actually missing some of the rule number two, rule number three. You have to make sure that your good milk being picked up and not
oh,
counted, not counted. I think you missed these two rules. You have the bad meal matrix, yeah, that part is okay. But you do not mark certain good milk, you should not be counted.
mm.
Those relationships should be ruled out.
So I
Okay.
need to check if it's bad milk and I also need to rule out the good milk.
Yeah.
Mm.
So let me give you this slice. Is that okay?
Yeah.
And maybe also the Java code.
Okay.
So what you should do is study this node, redo it by yourself. My code is for you to reference, but not to copy, right? You
Yeah.
know what I'm
Yeah.
saying?
Yeah, of course.
You're not going to improve. You just copy my code. Actually, not going to improve.
Mm.
Key point is that how can you come up with a rule? Because in the real competition, you are not going to see the same problem,
Mm.
but you will see some problem that is this kind of filter problem, filter out the possibility, not possible parts.
Yeah.
Okay, so and also right, the technique that used right here, one thing is this rule out problem. One, not, another one uh, is the matrix of who took what information.
Mm.
That two-dimensional matrix is key as well.
Okay.
Okay, counting for maximum that I think is easy. The part I think everyone can get it.
Yeah.
Everyone know it. But the
Mm.
rule I think is usually who may be wrong right here. Okay.
Mm.
Any other
Oh, I have a
question?
question.
Yeah.
Yeah, I have another. So like I'm ruling out like I'm checking which milk is suspicious, but if a milk can only be good or bad, if I check If I find which milks are suspicious, why do I have to like rule out which ones are good as well?
Because yeah, which one is good? Actually, what happened is which one is good, you don't need to see how many people got affected. That meal is good, so you just directly go out.
Oh,
Yeah. Good milk, no need to check.
okay.
Yeah. The key point is this one.
Okay, okay.
Mm. The most more difficult part is not the coding part. The more difficult part is how you summarize and get these three rules.
Yeah.
Yeah. I think this is very hard to get.
Hmm.
In say half an hour time, because you need to code in time, in roughly 30 minutes time, you need to come up with these rules that specifically be the right answer. It's very hard, I would say.
Hmm.
Yeah.
Okay, so I need to like find the pattern before I start
Yeah, you
the
have to really, each problem, you always look at the nature of the problem. What do they want to have
oh.
before doing coding? You cannot solve this kind of user code problem by just keep coding and tuning something. That won't help. Okay, that won't
Hmm.
help. Usually,
Wait,
it's that as long as you find the right rules, right algorithm, it should solve the problem. Yeah, question?
how do I know if I have the right rules? Like, what if like my rule like misses a test case, or how am I supposed to know like which part of it I'm?
You have to make adjustment by coming up with some new assumptions.
Oh, okay.
That part is sometimes very tricky. That's why user code is so hard. It's like you think it one way, but actually you may miss something. So for example, maybe this time is three rule, maybe for another exam, there are five rule needed.
Mm,
And then you just come up with four. There's a number five rule you never figure out. Then maybe two test case you never pass.
okay.
That's very easy, very natural. You know what I'm
Mm,
saying?
yeah.
So to be able to look at the problem and then seeing from different angles and come up with these three rules, that I think need experience and also keep practicing and making sure all kind of problem. That's why I want you to go from the very beginning of the user code problem 2015 or older one, because the reason not because that you cannot solve the typical one, but because we want you to see more problems.
Mm,
More problem, there will be more nature of the problem you will see,
mm,
and you will train yourself more
okay.
broader.
Yeah.
At this moment, you want it to be broader and also deep enough. Okay,
Mm, okay.
okay.
Yeah.
Any other question?
No. So
No,
should I like keep going in 2015 and do silver, or should I go 2016 and do bronze?
up to you.
Okay.
Up to you. You can do 2016. You can do this 2015, jump to 2018, jump to 2020, and then go back to 2015 again. Up to you.
Okay.
Because what I want to say is that 2020 and lower, you will need to have dynamic programming idea. Usually, some of the, if you don't have the order n log n, usually it cannot solve the problem.
Mm,
Okay,
okay.
so that need more technique. So the problem is like getting harder. But if you always do these kind of problem, you will get bummed out. I think you will burn out.
Okay.
Okay,
Okay.
so a good mix of everything, I think is okay. But we really suggest that right now maybe more of this and later more of this and then later more of this.
Okay. So
But if you do jump from here to here to here, you need to remember which one you already done. Okay.
yeah, of course.
But you can jump hop around. Yeah, it's okay. It's
Mm,
actually no one say no, but making sure that if you bump into many typical problems and you cannot solve any one of them, that means that over your capability already.
okay.
Then that does defeat the purpose of training.
Okay.
You may get extremely frustrated. Then then okay, not good.
Okay.
Okay?
Yeah.
Bottom line is that we still want you to at least solve the problem 1, problem 2, these two maybe 10 out of 10. And the third one, if you can do like 5 out of the 10, so you overall 25 over 30, you will pass 800. You will have good chance to pass.
Okay.
This one, nobody can guarantee you can get 10-10 in the problem 3. You know what I'm saying? But these two, you have to be able to really handle them.
Okay.
If these two you cannot do 10-10, I think you are out.
Okay.
Your chance to get 10-10 here is low. And right here, if you do have like 7-10 and then 7-10, you are out already.
Okay.
Right? You want to say?
Yeah.
Okay?
Okay.
Okay, keep working hard, okay? Let me know your progress and we will discuss, okay?
Okay.
Good night then, bye-bye.
All right. Thank you. Bye.
Bye-bye.